In this video we will talk about zero force member in trusses. So zero force member, it is a member which has zero magnitude of force inside it. So by directly looking at the truss we can say that this is a zero force member. So there are some particular pattern of trusses in which there is a zero force member we can identify, and we can directly say that this is zero force member. In many of the questions in gate exam or other exams, they ask about the force inside the bar in one of the truss, and then we have to we do not have to calculate anything, because it is a zero force member and we have to directly put 0. So that is a trick question, and we will discuss some of the cases where zero force member we can directly tell in the truss. The first case is two members are connected without any force at a connection point. So there are two members connected and there is no force inside, means connected to that particular connection point where two members are connected. So here if you see, this is the truss where four joints are there and five members are there. Okay, so these four members and one diagonal member, so five members are there and four joints are there, A B C D. Now force is at B point, and you see here C point, there are two members connected, and the second condition is without any force. So there is no force at this joint C. So this is a joint C where two members are connected, and if we draw a free body diagram of this joint, then these two members, there is no force acting at the point C. So force at connection point, there is no force at connection point. So these two criteria are met, and now we can directly say that this both two forces will be 0, because both these members are 0 force and they do not take any load. So this diagram BC and CD are redundant and they cannot take any load because force is at point B. So now these two, we can directly say there is no force inside these two members. So these two are zero force member, and the question comes like, how many zero force member are there in this truss? So the answer will be 2. Like that, there can be many possible zero force member inside the truss, and this is a direct questions comes every alternate year, and it's a very important topic for gate examination. The second condition is if three members are connected and two members are parallel. So two members are parallel. Simple criteria is three members are connected and two members are parallel, one is at other angle. So if you see here, this is the example, this is the truss, and here if you see this is a triangle, inside this there are so many triangles. So if you see at point E and D, point E, if you take, there are three members connected, one is AE, EF and EB. Similarly at D point, BD is connected, FD is connected and DC is connected. So if you take this joint and this joint, three members are connected at these joints, and if you see, two members are parallel, three members are connected, two members are parallel. So these two members are parallel, AE and EF, and the other one is at some angle. So we can directly say that BE will not take any load. BE is a zero force member, and EE will be equal to EF. So both these member will transfer load directly because they are parallel, and EF, even if it is not at 90 degree, that will be zero force member only. So EF, similarly due to symmetry, BD will also be zero force member because force FD and force DC will be equal, and three members are connected where these two members FD and DC are parallel and other member is at some angle. So these two are the zero force member, and now these two are not taking any load. So this diagram will be equivalent to this diagram, because we can remove those two, we can remove these two members. And if we now look at the point B, we have to look at the joint only, that is the key. We have to look at the joint only, we do not have to look at the force it is transferring to the line, this line of action is passing through B point. We do not have to look like this, we have to look at the B point. If we look at this B point, there are three members connected, AB, BC and BF. So like this, AB will be equal to BC and FB force FB will be equal to 0. So this is also a zero force member. So now only triangle remains and there is a force, so we can also remove this. So there are three zero force member in this particular problem. Likewise, there is a last criteria in which we have, if two members are connected and force is parallel to one member. So this is 3-member connection where one is the force, but here instead of the member there is external force. So if you see, this is the diagram, as similar case in the first case, but now the load is not acting here, the load is acting horizontally at C point. Now if you see, we have this B point where 3 members are connected, but they are not like this criteria, so there will be some load, we cannot say this is a zero force member. If we look at the C point, and in draw a free body diagram of the point C, there are 2 members FBC and FCD are connected, and one is the force. So now here the criteria is 2 members are connected, yes there are 2 members, and force is parallel to one member, yes force is parallel to FBC. So we can directly say this force will be equal to FBC but in compression direction, because both these two are in same direction. So we have to take summation of Fx equal to 0. We can say F plus FBC equal to 0, where FBC will be equal to minus F. So this is how we can calculate. But now if you do summation of Fy, we can directly say CD will be equal to 0, force in CD. So there is one zero force member in this particular case, that FCD will be equal to 0. So this is how we can use the concept of zero force member, and we can directly find there is no load. So this will save the time, and also it's a very trick question in the GATE examination. Thank you for watching this video. Please do share and subscribe the channel, and see you in the next video. Thank you guys.